And good morning, good afternoon, and good evening, everybody. Welcome back into the Dragon's Den. My name's Digital Dragon, otherwise known as Luke, and I'm a 3D printing variety streamer here on Twitch. That means we do everything from machine unboxings like our Centauri Carbons, our X1Cs, the Centauri Carbons, to full-up printer builds like our Vorons over here, beta testing like we did with the the box turtle. Wow. And various hot ends. Yeah, so that's a little bit about me. Welcome on in, Shrimp Father. How are you doing tonight? Hope you're doing well. I apparently am in need of some more caffeine, so let me grab one of these so I can make myself a little placemat and open up one of my Black Rifle energy drinks, because that was a little crazy. I hope you're doing well there, Shrimp Father, aka Martin. I hope everyone's doing well this evening. So in the last stream, we were working on the Manta M5P, and we had everything up on the rig. Doing good, just made a pot of coffee. It's just me and the fur babies. The missus is working second shift today. Oh, well, that sucks. But yes, time alone with the fur babies is always fun. So yeah, so on the last stream, we were working on getting everything set up. We had the rig up here on the bench, and we had the Manta M5P and the CB2 up, running, and talking. And then we were working on getting things talking to the toolhead. I did get that working. I'll kind of show you how I managed to get the toolhead flashed. I had to work on some more configuration, had to run downstairs and grab the cable for the beacon so I could get the beacon plugged in, and got that talking. And then I hit the point that I'm always happy to see, which was an immediate shutdown due to an ADC error, which is ADC, the analog to digital converter. It's basically saying your thermistor is unreadable. And that's a good thing, because that means that it's gone through and at least the syntax of all of your configuration is good, and it tried to start up the system. So that's a good place to be in. Hey, Eagle the Dragon, how are you? I'm feeling good. Mrs. Dragon, your sister's feeling good, and everybody else is doing good as well. Yeah. I did hear from Mama Dragon, which would be my mother, today, and sounds like they're not talking about surgery, or at least not any time in the near future, so that's good, if that's one of the things that you were wondering about. Okay, so now that everybody's caught up on family stuff, so by Sunday I was able to get the toolhead flashed, and we took the ADC error. I grabbed a thermistor here, and like I said, it's always good to have spare, just standard thermistors laying around. Plug these into the thermistor ports on your board if you're running toolhead wiring all the way back, and if you're running a bed heater, plug these into for the toolhead and the bed heater, and you're pretty good to go. You can get past that ADC error, and now you're up good and running. So that's kind of where we were at. So how did I get the board flash? So to flash the board, you need to connect. It was a little bit higher than it needs to be. You need to connect to the USB port of this board. Hey, Free Heathen, how's it going? Welcome in. You gave me a shout out to 24 viewers. Well, thank you, my friend. Thank you. Now, nicely enough, the USB port is these 4 pins right here. You say, well, nicely enough, there's not enough room to get to them from the back, and there's not enough room to get to them with a connector from the front. And you might be right. But then when you just make a USB cable by, luckily this already had an end cut off. So, you know, pinned out a JST, plug that into the socket, and what I was able to do, you're going to love this, line it up, making sure that the 5 volt and everything's in the right place, kind of jam it in, and it's jammed in at an angle so all 4 of the pins are pressing up against the contact that you would solder to. And this gives you a solid enough connection that I was able to flash CANBOOT onto the board via the USB cable, pop that off, plug the CAN bus wire in, and then flash the board via CAN bus with Klipper, and now we're up, running, and talking. Then I took the next error, which was couldn't talk to the beacon. And that's because, excuse me, we hadn't plugged the beacon in to get the serial port for the beacon. So then we had to connect that up, and lo and behold, everything is now up, running, and talking. I have taken the rig back off the table because the plan now is to actually mount this in here. If I can get this on here without damaging anything. Okay, and we've seen this before. We've got 2 power wires. These are power cords. These are the 2 cords that provide mains voltage into one, the 800 watt 24 volt power supply, and then 2 mains voltage going into the heater up here at the front. So this is the PTC heater. This is the mains heater that goes into the chamber heater. So we'll have 2 SSRs in the unit right here. One's for the bed and one is for the heater, that will then go out via this cable. Actually, let me double check that. That one goes there, that one goes. All right, one's going to the heater, one's going to the heated bed. Regardless, we have, I think the heated bed is the one that actually goes into the, the heated bed is the aviation, the 4-pin aviation connector, and then the one over here that looks like a standard plug cable is the one that goes into the chamber heater. It's kind of long-winded and stuff, I know. So what we've got in here is we've got the cable that's provided with the Bluestorm Terra hot end. This is the cable for the beacon probe. We've got the cable that I poached from the SB2209 that we used to connect up the CAN bus for the tool head. I do have some, I just ordered today some 3DO cable. It's a 4-conductor cable, very similar to this. two 20 gauge for power, two 24 gauge for CAN bus, and the connectors so that I can make my own connectors. And we have one of two things. We can either extend that cable or make our own cable for this tool head if it needs to be longer than, say, 3.5 meters. I will just go ahead and make a whole new cable. The cable that comes with the Bluestorm Terra for the beacon, this is a 5-meter cable. And since this is a 600 by 600 by 1,000 meter printer, or excuse me, 1,000 millimeter printer, it may be required. So we'll adjust as we need to. And I'm going to move this over here because if I leave it there, I'm going to hit it with this and knock it over. So the plan at this stage is going to be take the main board out of here, and we're going to put this board in. And I think my plan, this should be long enough to go through the standoffs that this board currently mounts into. We can either do it low or we can do it high. I'm probably going to do the den rail low, and that will let me get to everything a little bit easier. And then we're just going to leave this on the den rail mounted up. Okay. I'm going to mount it in this direction with the USB cables facing up, the network cable facing up, and the power connections facing down. And that's because the existing power comes around the bottom of the board, loops up, and in this side of the board. So I think what we're going to start with is just undoing this board and seeing how much room we have to play with to move this around a bit. We'll get some of these extra cables that don't need to be in there out. Well, that one's tied in. This one should be mounted in there. How are you going in there? Okay, we cut that zip tie, we'll get that out. And once again, the plan is to do minimal changes. Okay, so what we're going to do is we're going to swap the controllers and get the new controller in. We're going to leave the standard power supply here. Once again, this is an 800 watt, 24 volt power supply. And we're going to basically see if that will work. If it won't, then we'll look at doing some other changes. I need to make sure that these drivers right here will work going through Klipper. I've seen some issues that people have had running external drivers through Klipper, especially these older ones. I was able to find out that these are most likely, I'm about 98% there, they're knockoff hand pose 5980 or 5970. No, that's wrong. Hand pose, what did I say, Waters? 970 drivers. So I should just need to set the configuration up to push over step dir and enable, and that's it. I shouldn't have to send anything else or have anything else configured. Like, I'm not going to have a TMC section or anything like that. The question then is what do I set jumper wise, right? So this is currently set for a TMC driver to do UART. I need to figure out, I need to figure out how to set these jumpers, and it might basically be just putting all the jumpers in. right? So we got that out. This stuff, what I'm going to do is basically just make sure that this stuff is semi-loose, like this bundle here. Might be easier to go with the overhead on this. Let me see. Overhead. Wow, that's nowhere near zoomed in, is it? All right, give me 1 second. Let's see if I can get a better angle by raising this up, bringing it over some. Bench side. Raised up, moved over, not that much of an angle. Bear with me, we're going to see if we can't get ourselves a better adjusted look here by getting this a little bit closer into the action. There we go. Because with this camera, I can at least zoom you in. I'm going to do my best not to yeet stuff off the bench in the process here. Okay, so we're here. Let me zoom you in some. Okay, so what we're looking at is this group of cables is pretty loose. There's some that are tied in over here, but this bunch of cables right here is tied in here. So I'm going to cut this clip and buy me a little bit more room, because what I want to do is pull this off and set it to the side, get the other one mounted, and then we'll take one off of this and put it on the other one. So make sure I get in there without cutting any wires. So this group's pretty free. This group is now free. That one's coming in. We'll cut this one. I need to snip this one. Another one up underneath there. I have to try and we'll have to work that one as we need to. How's it going, Waters? Yeah, dragging, knocking things over? Never. How many times have I had to dig stuff up off the ground? Hey, GTR Dad, how's it going? Cold? Old maybe, but not cold. Okay. And the good thing is I do have... Hey, thanks for the follow, Extreme Error. I'm going to try and keep these over here where they're semi-separated from the rest of my stash. And with those four, I'm just going to see kind of what I have as far as movement. It looks like I'll be pretty good. I've got power coming in here to this jack, which I cannot tell right off the top of my head what that is. Signal for the bed. Power in. This is another negative switch. That might be for the tool head coming in. bed out. Oh, that's a fan. So this is the hot end fan. So this would possibly be a controller fan, bed out, and then this is power coming in from over here. So that tells me what we've got there. I will take these off. So what we're doing at Extreme Error, don't know if you've been around the channel that much. We're in the process, so this is the electronics of a FabTop Optimus P1 Pro. The only difference between the Optimus P1 and the P1 Pro is really there's an enclosure and a chamber heater. But this is like an $8,000 printer. It was made in Sweden. This is down at, the printer itself is down at Ecovate 3D. I've been granted permission to work on it and try and bring it back to life. This is just the electronics box off of it. We did some work on this before where we brought this back to the house and the wiring was a horrendous mess. So you'll see, whoa, stop, there we go. So you'll see all of these Wagos in here. Before there were screw down terminal blocks, a couple of them were snapped in half, and looking at what was there, and tracing wires, there was like 24 volt bridge directly to ground, and things of that nature. The wiring was a mess. So what I ultimately decided to do was get rid of the terminal blocks. We mounted a piece of DIN rail here. We added in some Wagos. The single stack Wagos here are the individual power in. Like I said, there's two power lines coming in. One of those is basically powering all the main electronics. The other one is just powering the heated chamber, or the chamber heater. So that's kind of what we got going on here. We go into an 800 watt power supply, out of that into a stack of Wagos here that we're then distributing the power through to the rest of the system. So we've got we've got earth, positive, negative, and we're using external stepper drivers. So these are hand pose. What did I say? Goodness, I'm gonna have to look at the text messages. I think we were doing it. Were we doing it in text? No, or were we doing it in? Apparently it wasn't text, so it's probably over in Discord. It's a problem. We wind up doing so many different communication channels. Yeah, I think they were hand pose HPD 970s. So basically with these being external, you use dip switches here to set the number of steps as well as the number of amps, so the current draw. And the way these are set up, they're set up for 25,600 steps and a 3.4 amp draw. Okay? And these are driving the Z-axis. They're wired in parallel as far as the signaling goes coming from the board. So they're coming off a single stepper and they're just wired in parallel. And then they're picking up power and their actual 4-wire to the motor from this connection. And these are going to NEMA 23 stepper motors for the Z-axis, and they are driving SU 1610. So that is 16 millimeter ball screws with a 10 millimeter lead, meaning one revolution, it travels 10 millimeters. So 1 centimeter for one full resolution of the ball screw. Yeah. And the reason there's so many steps set up for them is to get that minute stepping, since each revolution is 10 millimeters. Okay. And then the way the board comes naturally, you would have TMC 2208s for X and Y. What we have here is, I believe this is a 2208 for X. Y is actually a, ooh, wow. There we go. So I think this is the original driver. This is a TMC 2208 driver for X. And then the Y driver here has actually been replaced with a TMC 2209. Right? Currently, and we have an even different driver back here for the extruder, but that's not going to be needed anymore because the extruder is going to be driven off of a toolhead board. We're going to stay with the 800 watt power supply that it comes with. It's 800 watt, 24 volt. Once again, the bed and the chamber heater are both mains powered. They're running off of these Photech SSRs. I would much rather see Omrons rather than the Photech, but we didn't want to change anything. We wanted to make sure that it ran. Right? Now that we've validated that it runs, we can go ahead and start making a bunch of changes if we want to. One of those changes will be the fact that we're running, let me see if I can flip this over nicely. Okay. We're running these aviation cables here for all the connections. So one of these is X, one of these is Y. There's a couple for the tool head. I think it was C and D for the tool head. One of these, I can't remember all of them right off the top of my head right now. I'll have to look at the spreadsheet. But I did go through and do a spreadsheet for each one of these. And we're going to do the brain swap. And I will go and hang this back on the printer. We'll connect all the cabling up and make sure that we can get motion and that it works. Once we verify that, then we'll see where we want to go from there. It is quite possible, like I said, that these old hand pose HPD 970 external stepper drivers here may not work with a Klipper based system because of timing issues, right? I've been reading up and there may be some timing issues. If that's the case, we can potentially pull these out and drive them with 5160s because we're still running everything at 24 volt. And I believe the 5160 Pros can do the 3 amps. If they can't, then we would get 5160 pluses, which are the external step sticks like we used in the VZBot. In which case we would just mount those separately. We could just print mounts for them, mount them to a printed part and VHB them directly to the back of the case here. and similar wiring setup. We basically bring signal and power from the board to the stepper. Well, signal from the board to the stepper, power to that external board, and then we bring the 4 wires up to the motor. So relatively simple. My plan though is to make as minimal changes here as possible and preferably keep it reversible. Okay? Meaning this is the way everything's cabled up here. I want to take this cable off of here and plug it directly into a port on the other one, on the Manta M5P. If I need to repin the connector, meaning the order of the pins on this board does not match the order of the pin out on the other board, I will document that in the same spreadsheet. So if down the road we go to bring it back into a stock configuration, we can do so. That's the whole purpose here, is to make it so it can be returned to stock as much as possible. Sound good? So what we'll do is, as we, I'm going to disconnect 1 or 2 more wires here. And just trying to figure out, so this one, my shorter one here, that's tied up is X. What I don't have is any marking on here, so I'm just going to write X on this with a Sharpie. I can trace the wire back. I have the wire traced. There's a marking on this wire here that just says 1. But I'm going to go ahead and just put X right there. We'll pull this one off. And this one says 4. Like I said, semi-random. I'm just going to mark Y on here. So we're just marking that wire so that we can put things back where they came out of. So yeah, so X is coming out of the A cable at the A cable here. Where am I going? Which way am I going? Okay. Yeah. So the X cable, yeah, is coming out of the A aviation connector, and the Y cable is down here out of the B aviation connector. So that's what it appears. So we've got those 2 out, and that should be enough for us to kind of move this out of the way. I will undo some more of these. I know where they're going now. Of course, the thin ones are going to be to the SSR and the bed. These are just, they're thin wires because they're just sending the turn on or off signal to the bed. We'll just scoot those out of the way. And then our other one, I think we might be able to just leave those in there for the time being. I'm going to take the whole Z stepper out because that's just going to get plugged into the other board directly. And you'll see that we have an E0 and an E1 in here, and that's because the E0 is the hot end. The E1 goes to a laser module. Not really keen on that, but that's what it does. And like I said, I'm just going to try and fold this out of the way for now and see how we're doing. The idea, once again, is just going to be to put a length of DIN rail right on there. Probably bring it this way. Screw that straight down there, and I may M3, I'm going to put a washer on this just to give it a little bit wider flange area as it seats down on there. Hey Shenanigans, how are you? Hope you're doing well. We're doing pretty good. We're back at the Optimus P1 electronics here. We have everything, I'm going to say, preliminarily configured on the Manta M5P. And all I'm doing is getting things kind of set up here so that I can install the Manta M5P board in here, and then we'll just go through one at a time and disconnect, reconnect, disconnect, reconnect. And while we're doing that, I do have a spreadsheet that I have over here that literally says, okay, let me bring this up. The spreadsheet is a straight up wire map. So cable A, so aviation connector A, there's only 8 wires. The rest of the wires are dead, not being used. And so 1, 2, 3, and 4 are going to the X motor. And then 5 and 6 are going to X minus. 7 and 8 are actually going, I need to fix that, are for the Y end stop. So are going to the Y end stop, but I have them listed as X positive. One of those does not make sense. So I'm going to double check. I have a feeling that it's configured to Y minus and X positive. And I say that because the tool head comes to the right, so that would be X positive, and the front, which would be Y negative. So I will double check these wires as I'm moving them over and correct this. But what I'm gonna do here is modify this spreadsheet to show the printer mainboard, which is the MKS Gen V 1.4, and then the new board over here. Oh wait. So this is the port on the MKS Gen 1.4. This is what the printer component is. And then we'll add the new board here. I wonder what I should do. Right, well, not right click, but click that, unmerge. So unmerge, I want to take this column, move it over here. Well, that didn't work as planned. Ay, ay, ay. Undo, undo, undo cut. Okay, let's try that again. Right click, cut. Click this one, say insert column after. Paste, there we go. that's sort of what I want to do. We'll delete that column. Then we'll add this one, and this one we're going to make BTT Manta M5P. And we'll be able to put in what this is. Okay. So the plan will be to take our Manta M5P as it sits on the mount and just go ahead and mount it. And then hopefully we'll start taking things off this board and plugging it in. And I think I'm going to have to undo the power cords to give me a little bit more room. Okay. So these two were these two together were power. And these were the toolhead power, so they may not be needed at all anymore. This is the negative for a fan, so this is most likely one of the fans on the toolhead, which was pulling 24-volt power. It will no longer be needed as well. So and ground. So I will pull these three out of the way. Because what we want to do is if these are power and they're not being used, then we definitely need to disconnect them or just cover them up. We don't want anything spiking or arcing, or if they, well, no, they're going to the hot end and the hot end's not installed or using that connection, we should be good. Okay. We wanted to go in this direction. Okay. So we have these two toolhead board ones. I am going to unplug them and plug them down into the unused slots. Not going to do any harm in doing that. And it will kind of keep them out of the way a bit. So that would be the laser slot. This would be the hot end slot. We'll have to do some wire management again down the road. I guess while we're at it, what else is going into that? A single conductor that was going into that board and is coming off of E. So what was on E? I have a feeling this was the laser like trigger. So cable E. So I have the extruder motor. This is going to go into the M5P. This is the extruder is motor 4. So it'll be, you know, the ground and yeah, for now I'm just going to grab these. We'll change the actual pin names here in a second. Then we'll have the laser. That's the laser motor. That went there. Okay, and the single item right here, which is cable 5. So cable number 5 was the laser enable pin right here. So this would be coming to the board to enable it, and then there would have been power also coming out of here that we have that comes around that we have marked as laser 24 volt and laser ground connections. We can keep those connected. We can take them off. It's not going to matter. This particular cable right here, I am most likely just going to wind it up like this. We'll put a new zip tie on there and call it good. I don't want to even connect that enable pin. Makes no sense, no need to. And in fact, this whole wire is not even going to the tool head anymore, because once again, these are connections that were going to the tool head. D and E were going to the tool head, and they're not being used at all anymore because nothing at the tool head, everything at the tool head is going via the CAN bus and the USB for the beacon now. So I'll cut this existing cable tie and we'll put a new cable tie in there. Yeah, I forget my Excel shortcuts just as quickly as I go to use them, just because as much as I live in Excel spreadsheets, I hate living in Excel spreadsheets for my job. So I do my best to try and stay out of them. Doesn't work as well as it used to. Okay, so we just bundled that one up over there. The name of the game here is going to be try and be as tidy as possible, and once again, don't make any changes that would be irreversible. Okay, that's some stuff going into the screen. This one was the Y connector, which will now be able to be pulled up as well. Y is going to be that second motor. X will be right here. This one will get pushed down and underneath. The wiring job, I will say, will be able to be a lot better if I really wanted to get in here and start, we'll say, hacking and slashing some of the wires. But as I've mentioned numerous times, I really don't want to do that. That would almost be a last resort type of thing. Hey, projects, how's it going? Projects, I apologize. I was, I'll say, in and out of your stream a bit today, trying to do a couple of things. Did you get the switch wire up and running? Did you get the switch wire up and running? Okay, so these are other cables NA. 5, 6, 7, 8. So these are end stops, and 5 and 6 are going into the X plus. 5 and 6 are going into X plus. So A, 5 and 6 are going into X plus. So what we're doing here, projects, is we're working on the Optimus P1, and we're pulling it off the MKS board and putting it over to the Manta board. And so what we're trying to do is line our boards up, and 5 is the signal and 6 is the ground, which is in the middle. So when we go to our X in stop over here, which is actually X men, by definition, we can call it whatever the heck we want. Let me look at the Manta pinout here. So on our X in stop, Mem1, the pin is away from the power, so the trigger pin is towards me, ground is in the center, and this wire is in the same orientation is going to be correct. So we can take this and plop it right into the X men stop, and that's going to go in just like that. And what we'll do, since we're here, is the pin for men 1 is PD3. So we'll come over to our spreadsheet and we'll make this Papa Delta 3. And while we're here, we know we're going to have our X motor over here. Let me just look at the cables and the orientation. So we go 4, 2, 1, 3. That's awesome. So So 3 would be 1B. One A, 2A, 2B. Okay, and that's going to be enable step dur ground. Oh, crap. Yeah, they should all still be the same order, because ground should be in the same spot, right? Where's ground? Ground was cable 3. Yes. Okay, so 3 is ground. Next cable to it is, which one? Four. Which order do these go in? Shouldn't matter. There shouldn't matter. Yeah. Should not matter. I'll dig that out. The good news is that the orders are in the same direction. So one, two, four. Okay, yes. The motor cables are in the same direction, so that's good. We did that. The Y end stop is going to go to Y min 1, and Y min 1 or min 2 will be Papa Delta 2. And we have no need to change the direction of the pen. This will come over here into the Y end stop. Okay. So what else do we have here? We're going to have this connection, which is a pain in the ass. It's a straight 2-wire coming down there. So this is going to be the bed thermistor, I believe. Because it's not in a wire loom. The other two are coming out of the wire loom, so I'm going to assume that these are going to be a chamber and a God, which wire loom is that going into? This is most likely going to be the D. What thermistors do we have in cable D? Toolhead thermistor. Okay, there's a 24 volt terminal black in the ground going into D. Okay, there's two wires that were coming into this area right by the thermistor cables. Let's see. We have 4 and 5. That is the T0 thermistor, or the E0 thermistor. So we'll pop those out. And where's our E0 thermistor? That is T0. Thermistors don't matter on the whatchamacallit. The other cables are 13 and 14, which are not used, which are TH1. So we'll go ahead and just put those in TH1 so that they're out of the way, but they're not used. Which most likely means that the other cable in here that I was pulling on is going to be the bed, because it goes into the 4 wire going over to the bed. And it is not long enough. We're going to have to do a pigtail for the bed, or an extension of these wires for the bed thermistor. Okay. We have another end stop here. Wire 11 and 12. Once again, going into the D, which is the BL Touch end stop. This is not going to get used. And we're also not going to use the verify 7, 8, or 8, 9, 10. 8, 9, 10, which is a BL Touch, because we're using a beacon and not the BL Touch. So we're going to have a set of wires here that are not used. I'm going to cut that there, and we'll bring this over and kind of loom it up as well. Let's kind of get these out of the way. Once again, I don't want to yeet wires, cut them off or anything like that. We're just going to coil them up, kind of pack them out of the way so that we can keep moving on here. Sorry, I haven't been paying attention to this chat. You went to a backup from yesterday. Okay. So far there's one wire which will need to be extended, but that's not that big of a deal. Everything else, I've got plenty of wire. There's a whole lot of wires that weren't used because they were using these, what is it, like 14 pin aviation connectors, which is ridiculous, but it is what it is. What was that to me, Waters? Because the answer is no. Who's a Delta 2? Pardon me, sir? What? Yes, Waters does have some of the foaming TPU. It's made by Recreus. Well, they carry one by Recreus. They are the only sellers in the U.S. that has it. I believe it's a company out of Spain, if I remember right. And I do not believe it's PEBA. I believe it's something else. Thermoplastic polyurethane. There we go. Now, I could come in here, make a little tag here and be like, okay, these are BL Touch. I'll try and make a little bit nicer tag, though. I may have some label making stuff coming in shortly. What else do we have? Wow, we only got one connector left on the board. What is this? And where is that going to? This is going to one of the servo connectors. And it's going up to the screen. So that's going to be one of the issues is we've got this screen. And yeah. Bum, 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 bum. Let me do some things real fast. BL Touch not used. TH1. This is plugged into TH1. Still not used, but we will put it into TH1. Let's call it. Goes into TH1. One of those will be into a pen. TH1 is PA2. And that would be 14. The other one, 5, will go into the actual trigger pin. So 14 goes into PA2. G and D. Okay. E0. It was 4's in the ground. And the other one's into PA1. Six and 7 are into HE0 and plus and minus, so that's the hot end power. We won't need those wires anymore, like I mentioned earlier. So that's the hot end power. And then we also had a fan ground, which was line 3, which is the PC fan switch. PC fan switch, part cooling fan switch negative. This will not be used either. So not used and not used. So once again, these will just be like quote unquote dead pins, so we can just bring that, loop them around with the rest that I just zip tied there and keep them out of the way. So we'll put that there. Throw another zip tie in there. Okay, so that's that, that's that. This is the Z. We'll just need to bring this around and plop this into the Z. Okay, let's go like this. I still need to figure out those jumpers. I think this is going to need jumpers at everything because the MKS board has jumpers everywhere. So we need to verify that. And then we've got one other connection down here that we need to look at, which was the aux1, which was going up to the screen. So that one we shouldn't need. This is the screen that we've got going up here because we're going to use a different screen. I think we have everything here. Oh, we got the laser enable. That was undone. These are not used. Mess with that later. Cable H was the chamber thermistor. H, chamber thermistor. And I believe that goes down into, yes, that directly, not used. This is the trigger for the bed. We'll have to disconnect it from there so we have the length to wrap it around here. We'll retie it down afterwards. So this is the auxiliary for the display, which we will not be using because, well, we're just not going to use that display. I don't think we can. Is there a tie down underneath there? Yeah, there's a tie down underneath there that goes into. So we'll just kind of tuck this out of the way. And there's our old board. So that's pretty cool. So we are now one board down. Good gracious, there we go. And the new board's in there. We'll have a few more things to wire up, namely things going to power. So this was the cable that was power to the board, which is now down in this direction. So I'll flip this up, I'll disconnect it, and we'll reroute it. Possibly come down and back around. So I'll have to reroute the power supply here. Let me flip this over on its side so that I can snip some wires and we can reroute that. Move the mouse. The hell thought it was great to put zip ties up there. Says the guy that zip tied the wires up there. Okay. Now I could bring these. There's one other connection up here. I could cut it and then bring it just straight down this way, or I can just keep it coming around the top, kind of drop it down here and do the plugins this way. I think that's what I'm going to do for now. Either that, or I could bring it down and under the board. That's always an option as well. So you run into the other wires you shoved underneath there. We'll run them this way. Just kind of bring them down with the collection that's already gone that route. Now, which connector are we putting this one to? Switch over here. So not what I wanted you to see. Change the active camera to that one. Okay. So here is our main power, 24 volt coming into the board. Yellow is hot, blue is cold. We're just going to route these, like I said, down and around with the other cables here. We haven't decided if we're going to put like a clear plexiglass or a smoke plexiglass or something here. Our power in, DC in is on the inside of this connector closer to this capacitor right here. So the two outer side are the heated bed ones, and then the two inner ones here are our DC in, with the voltage in, or the voltage side being the center two pins. So our hot's going to go on the inside there. And I like how it says HBVN. I mean, it's voltage input, but it's really, in this case, voltage out. This one will go right next to it. which once again, the blue is our negative. It's cold is the way I think about it when I use the blue and the yellow. Come here, wires, work with me. Just want to tuck you down there where it's sort of nice and out of the way. Once again, these two wires here are bed trigger wires. They're going to go in the next two terminals. I don't have enough play. We'll snip that. And we'll reattach it to a different tie down. A few of them in there we can play around with. And once again, the hot side of things is in the middle. So this one, the red one's going to go next to our yellow. And once again, these are smaller wires because these are just triggering the SSR. They're not carrying a high voltage. Hey Pezliz, how are you doing? And we'll be able to come around and add these to a couple of more of the tie downs that are here. We'll just snip that one, add it in, and then same, well, we won't need to snip one out of the other side. The other side will just be there for us. Be careful when you're snipping your wires that you do not inadvertently snip the wire when you're cutting your wire ties out. That leads to bad days when you cut your wires. That one, whoops. And that was going to be bad because that didn't even, apparently I did not have that in and I did not do the pull test. All right, passed the pull test that time. I'm glad you had a great nap, Liz. I took one of those today myself. Always nice to have good naps on the, you know, on lazy, rainy days like today. Okay, so that one there. We'll add this one to that one right there. And I'll keep that one tied down. Okay, so we've got the bed, we've got the main power coming in. We don't need either one of our tool heads. And then this is the high voltage. So if we do decide to switch up and go to a higher voltage and do like a 24 volt to the board and the XY and 48 volt or 48 volt to everything and just 24 volt to the board, we can do that by bringing high voltage into these drivers here. Let's see, what else are we missing? We've got the thermistor wire that we need to extend, which is right here. And I would just say, wow, we could just redo those wires, but I am not dealing with those pin connectors down there. I will simply undo this, and we will extend these wires. This appears to be some 20 gauge black and red wires, so we'll try and find some 20 gauge black and red that we can just do a little extension with. Even though this is just basically a signal wire that I'm playing with right here, I do not want to make this a smaller wire, right? Don't do your a small wire for your pigtail. It is a thermistor. It will, not will, but it may throw it off if you switch over to a smaller wire size. But we'll do a pigtail, or we'll extend this out. We just need to go here, so it doesn't need to go but a few inches. So we'll probably make a pigtail, 4 or 5 inches. Do a solder job, and we'll be good to go. Now the question is do I have any 20 gauge black wire over here? 20 or 18 gauge, that might even be 18 gauge, that I can use to make a pigtail with. That looks to actually be bigger. Yeah, that might be 18 gauge. I do have some 18 gauge wire here. It's PEP wire instead of silicone wire, so it will appear to be a different size, but it should work fine. We'll just snip the end off, peel our thing off so we can reuse the connector, because why not? We'll make an extension, we'll do our solder joint, we'll be good. We'll use our standard little solder connectors, which should work for these. No, those won't. Where's my other set that has the different sizes? Why would it be in plain view? Because that would be helpful, beneficial. I done lost things again. I know that's going to shock some of you. Oh, there we go. One will use that rather than the BEP. But I still need my butt joint connectors. Nope, not in there. You guys didn't see what I did with my heat shrink butt joint connectors, did you? One of these days I'm going to get organized. And hopefully sooner rather than later. Hopefully sooner rather than later. All right. All right, Mama Liz, I may need you to yell at me to organize my stuff. May need somebody to put me on blast to get me off my butt to organize again. So I know I have a little container that's got multiple different sizes of these shrink wrap connectors. Just the ones that I've got here will not work for the size that I'm trying to use. They are not in here in the wiring stuff. Not on the desk. And I do hope that you all are sitting there heckling me, even though I can't see it, so I can read it when I get back. But I probably deserve to be heckled for continuing to lose connectors and stuff. And I know exactly what it looks like, which is probably why I can't find it, because, you know, I know exactly what it looks like, and I'm going to look right past it like 8 times as I'm trying to do this. Oh, that's his stuff. I don't think I had it down here, but I will double check. No, no, and no. All right, let's see if I put it over here because I was trying to be organized. Okay. So at what point do we say the heck with it, we give up and looking for these and we just solder it the old-fashioned way? I feel it coming up. That inevitable sense of failure, which means within like 30 minutes of doing it, I'm going to find the connectors I was looking for. All right, one quick check over here. I don't think it's over here, but we'll check real fast. Nope. Tons of different connectors, but not the butt joint connectors that I'm looking for. Okay. I'm going to have to give up for now, and we'll pick up that search at a later point in time. Because like I said, the other ones are going to be too small for what I need to do. You'd have to look in the mirror. An Optimus robot that actually works, unlike the one from Tesla. Yeah. Well, and then this robot, you know, this guy right here that you're seeing leaning over the electronics box here is the one that keeps losing his solder joint connectors, which makes things exceedingly difficult to work on projects when you keep losing things. And by losing, I mean misplacing. I haven't lost them. They are somewhere in this room. Where in the room? That is the million-dollar question right now. Because stuff continuously gets shifted around in here. And that would be why I'm now at a loss. Look like IRCFA stuff. Okay. Time to stop looking, and we'll just do this the semi-hard way by just doing a straight solder connection. The part that sucks is going to be trying to solder in here. Oh, point of no return. Using the solder joint connectors would have been so much simpler. The hunt continues. Yep. The hunt continues. Ooh, you know what, Waters? Could I have put that in the tool chest that I take to the shows? Guys, give me 1 second to go downstairs real fast and check that. It may be in that tool chest downstairs. Give me 1 second. All right. As my brother-in-law would say, bingo! We found it. Guess what's going to be added to the cart real soon is another one of these that we can use. We'll leave one here at the bench and one at the one in the box. So what we're looking for here is 22 to 18 gauge size. It's going to be red. So we want to grab 2 of the red ones here. As you can see, we've got all different sizes. I've got a whole little container of these size, which would be for the smaller wires that we do on tool heads and stuff like that. That's 26 to 24 gauge. And rather than use the FEP, I'm going to use these wires here. Said this should be about all that we need. Oh yeah. Yep. Thanks for the resubscribe, Waters. What we'll do is we'll just make these the same length. Do these one at a time. Let's pull off a bit of the insulation. Go ahead and grab our heat gun and get that out and ready. And we're going to do the black first. So you want your two wire ends to meet in the middle where your solder is. And then what I do is try and shrink it on the edges around the wire first. And then I'll come back in the middle and concentrate the heat where the solder is to get that solder flowing. And I then try and hold it somewhat straight. It's pliable now, so if you need it to go in a curved shape, you can make it go in a curved shape right now. I'm going to try and hold it here straight for a little bit and let it cool off some. And you'll be left with a nice strong solder joint that is waterproof because it's shrunk around both sides of the wire. Do the other one. Kind of a pain. You see me really getting in there on the solder side of things. I just want to make sure that that solder does heat up and flow. If you need to, you can rotate it around, or even better, use your deflector, which will bring that heat around both sides. And you can really heat up that solder joint by doing something like this. Just be careful, because now that's super hot as well. And once again, kind of hold it straight while everything resolidifies. Okay. Now we'll go ahead and do the other end, and we'll get ready to do our connector for the JST. All right, these are sucking. And it really doesn't matter. It's a thermistor, so it doesn't matter which direction it goes in. As far as the black or red or whatever, you can put the red in the ground, or I'm sorry, the black into the ground and the red into the signal. You know, your preference. Most thermistors are just white. Okay. That one was not done well enough. Now the hard part is with the size of this wire, I may have to do what I suggested not doing and go down just one gauge so that it's easier to get the JST connector on. Not a bunch of frayed wires, because frayed wires is not good. Okay. Connector goes on that way, and signal is towards the fuses. Red would be on that side. Okay, we'll do the black. Need another connector. So is everybody having a good night tonight? And is everybody getting ready for Halloween? I will say that Mrs. Dragon and I have not done anything for Halloween. We just haven't planned at all. Most of our neighborhood kids go to their local church and do the church trunk or treat. So we don't have any kids running around the neighborhood. That's kind of the double-edged sword, because some of the kids we have in the neighborhood are, teenagers, and it's a different type of trick-or-treating when you're that age versus when you're, 6, 7, 8, 10. Okay. Now we should be able to feed this up underneath everything. Just like that. Under there, bring it around and plug it in. So we have a bed thermistor. We've got the other two thermistors plugged in, even though they're not going to be assigned to anything. They're just plugged in because we've got our extruder and the other one plugged in, that they're not going anywhere just yet. If we're not going to use them anyhow. This will be the Z that's coming over to the two externals. Like I said, I think we need to set this up as standalone dump mode is how it's normally referred to. And then we'll let all of the driver deal with it. The external driver. And we're pretty close. Like I said, the tool head is right there. We can plug the tool head in directly into this board now, and we'll plug things in and show that it comes up, and we don't let any of the magic smoke out. That goes over there. This goes over here. This will go down here. The bed I might have to pop back out and put in another wire. We won't have a screen at the moment. And if I remember right, the screen also drives the reset. Let me... Let's look at the manual real fast for the Manta M5P. Basically, we're going to be looking at the stepper driver. Basically, we're going to do standalone mode, which will be page 10. So stepper in standalone mode, so this would be your 4988, DRV 8825, so forth. Connect jumpers MS0 to MS2 according to the microstep chart. Yeah, I think it's going to be all of them, because I really don't think this mode matters. And I mean, we can try leaving it completely out and not having anything jumpered. See if I can get this. Hey, Jedi Spidey, how's it going? Hey, Timor, welcome in. What we're working on right now is trying to get our board completely cut over to our row. All right, mental brain fart. Give me 1 second. What do we do with the other board? It's right over there. It was like that. Yeah, these get flipped around. We're trying to just get everything set up, and in this case, we've got this like false stepper driver board, which interestingly enough seems like it's Holy crap, this isn't wide enough. This isn't as wide as a standard step stick. Is it? Why is it? Okay, those are in. Oh, there we go. There we go. Okay, so we've got a TMC 2209 for X, TMC 2209 for Y. We have X and Y end stops. X is configured for going into the positive direction, so this is a max end stop. Y is a min end stop because it holds to the front right of the printer. Z, we have the step stick here, and as you can see, we're only providing 3 wires. We're not sending ground. We're just sending step, direction, and enable over to these external step sticks over here, or not step sticks, these external drivers that are very, whoops, come on now, that are reminiscent of like drivers for a CNC display. Right? And then we've got the other 2 connected. They really don't need to be. It was more or less just to try and differentiate which one was which, because one of them would be for the laser head and the other one would be for the standard extruder, which we're not going to need either one of these. So the entire, the entire E aviation connector is not needed at all. And D is the Z, so we definitely need that. The vast majority of the D connector we're not using. Actually, I take that back. We're not using D at all because all of D is basically just these 2 thermistors, which we don't need because we're not using anything in the toolhead. So we could literally pull some more stuff off the board and go bare minimum to what we need to run on this board. I think that's what we're going to do. Because we're not, like I said, we're not running the E end stops or the E stuff because we have a toolhead board. Let me grab the tape. We'll create some labels. We'll label these, and then we'll just undo them and kind of pull them out of the way. So I hope you're doing well, Spidey. How goes the venture? Hopefully still going well. All right, so we have E0. E1 motor. TH0, TH1. So we make those labels, we cut these out. Hey Kenneth, how's it going? So I was going through and I was kind of plugging these in even though they weren't going to be needed. And I just kind of made the decision, nope, let's take them back out. They're not going to be needed. because we're using a tool head board. Let's just keep things as neat and tidy as possible. So we'll coil these up. We won't be using this entire wiring loom basically. This particular loop here that I'm pulling out, this aviation connector, this 14-pin aviation connector won't be used. Either D or E won't be used because this one has now been completely unplugged, and the other one's now completely unplugged as well because we don't need the thermistors because they're running on a tool head board. So, yeah. Let's just try and clean stuff up, keep it clean, keep stuff out of the way. Only connect the stuff that needs to be connected. Anything else becomes a distraction, right? It's there if we need it. If we don't need it, then don't use it. Pull these out, and they're basically going to loop around on that stack. Just tied down at the bottom. Let's grab a couple of these. Hey, Zombie, how's it going? Hope you're doing good. Okay. Let's trim a few of these. All right, so we're looking a little cleaner. X, Y, the Z cut over to these. X and Y end stop. Fan for the CB1. The bed thermistor, which will pop out, and we'll put a false one in there for now. The bed trigger and power in. We don't have any other fans here. We're not running fans on our board just yet. If we do a plexiglass cover here, we'll probably cut out a grill for a fan and mount a fan directly on that plexiglass cover, and we'll come in here and plug it into, one of the CNC, maybe the always on fan or something, and we'll put that right over the top, blowing down on the driver. Yeah. So I think that's pretty good. Everything's there. Everything's out of the way. We'll need to plug up the tool head and the beacon. Get the sharp things out of the way. So let me go this way so we get a little bit bigger view over here. I'll pull you guys back. All right. So, kind of there against these connectors. We'll have our tool head. Let me see if I've got something
rigid yet non-conductive that I can use as, well, sure. Don't want to use that one. We'll grab this whole thing. Why not? A magnet with a sheet on it. Flip that over. That makes a little platform that we can put our tool head on. And we're going to need to let's add another board to that as well, just to make it a little bit more rigid. Here we go. We need to plug in a couple of wires. One, we're going to have our CAN bus wiring. And this will get interesting because we're going to need a constant 24 volt and our CAN bus. What we did last time was pulled our 24 volt via a little run, so to speak. So let me see, do I still have those pigtails? What do I do with those pigtails? Seriously? Now what did I do with those pigtails? I didn't throw those away, did I? Should not have, because they had the Legos on the end of them. What are you doing? Making pigtails. Didn't you have pigtails? Yes, I did. And then I don't know what I did with them. Hey, there's one. Which means there's the other. Are they going to be long enough? Probably not. Because we'll have to pull 24 volt and power, or 24 volt and ground. 24 volt from there, ground from there. You know what, for now we will that's not going to get me far enough. Let me make just some longer pigtails or grab a couple of wires that I can use as longer pigtails. That one will work. Me and my multiple lengths of wire here going, don't know. Maybe, no, yes. So this one's long enough, but I don't want to use this one because it's already set up with spades. But you know what? The hell with it. I've got connectors. Cut them off. You'll be fine. You'll be fine. We're going Wago to Wago, so strip off. How much wire do you need to strip off for a Wago? Anybody know? One, there's a measuring line on the side of the Wago. Two, it's 11 millimeter. Just so you know. Oh, I hope these are going to be long enough. what I'm going to do is I'm going to pull the wire for the laser. Be smart. That's the positive side over there. You're working with the black, so undo the laser. There we go. These are just straight through Wago connectors. So we got ground, we've got power. Which means now I need to put right on one side, back on the other. And hope that we are still long enough, not, scooche, scooche, scooche. Hopefully we are just long enough, just long enough. My black's too short, dang it. Fine, we'll swap something around. See if we can't get another extra oomph. Does that get us what we need? Barely does. It's okay, we just need to get to one of the two CAN bus connectors. This is show and tell night here in the Dragon Den. This is not final wiring by any means, especially when I just pull the wire out. Come on, wire stretcher. There we go. And laser, laser. The other one was a ground wire for one of the external drivers, so we do need to put that back in. All right, there we go. So we've got the connection side for our tool head. We're going to bring our tool head back up here. And we're going to connect our CAN bus connector into the tool head, like so. And then we need our connector for the beacon probe. So let's fish this down there. Need to plug this into our USB connection. We'll plug this side into our beacon probe, like so. Now, which one of these goes to the chamber and the bed? That one. This is the one that goes power supply. Power supply. Who's going to the power supply? One goes to the power supply, and that one goes to this. I'm just trying to figure out which of the two cables I need to plug in, because I don't need to plug in both. I just need to plug in the one. And and hope that we don't take down like the entire Dragon did when we flipped the switch. Okay, so we're plugged in. We've got all of our cables to the tool head. You can see obviously the power's on because the switch was on, and our e-stop is on. We've got lights on down here. We got lights on our tool head. Oh, it's the fan power supply, or the power supply fan is going. Once again, we've got nothing going on the screen because the screen's not connected. Yeah, the filament runout switch goes to the screen, and then so the plan is we're going to run either HDMI or a DSI display. As you can see, our fan on our, well, maybe you can see, the fan is on our CB1, keeping everything nice and chill. So let's go ahead and see if we can get to our screen. I'll go full display here. And this is Optimus P1 local config. We're going to go ahead and click on that and see if we can get to the web interface of the CB2. Hopefully we don't have to remote the wireless any. Seeing as how it's all in an enclosed case. Okay, power, ground, signaling out. CAN bus connected. Come on. All right, I'm curious. We're going to go into PuTTY and see what the issue is. Optimus P1 local. Could also be that it's set on the config screen. Oh, I bet you I know what the issue is. Wireless isn't set up on it because I was doing it over a wired connection. So let me come over here and grab my network cable and see if I can't zoom it across here without knocking a bunch of stuff over. Oh, sorry about that. Up or down? Looks like down. Or it feels like down, I should say. Here we go. All right. We got a connection. Don't mind, wires going everywhere. We have a connection. Let's do a reload. Bada bing, bada boom, we're up. MCU shut down ADC out of range. That was to be expected. So I'm going to just push the E-stop, or actually I won't. I'll shut this down nicely. I could do this hot. You really shouldn't. Okay, and what I'm going to do is carefully, so I don't eat that cable, I'm going to unplug the bed thermistor, and we're going to plug in a standard thermistor here. So once again, this is just tricking the, well, not tricking, it's letting the tool board or the MCU get a thermal reading. Okay, so we'll just set that somewhere, and we'll release our emergency stop switch. We'll push the on button. This will come up. And it doesn't know that it doesn't have a motor attached to it. So we'll have to test some of this out. Maybe tomorrow, maybe another day. I am planning on going down to Ecovate tomorrow. I need to go pick some things up that just came in, and you know, it's tacos. They have tacos. So we're up, right? Once again, we can now get a thermistor reading from our bed thanks to our spare thermistor. This is why you always need to keep some of these laying around. We're getting a thermistor reading from the extruder. We're getting a temperature reading from the beacon coil, the CB2, and the Manta board itself. Yes, the taco truck. Jedi Spidey knows the taco truck. So we don't have the ability to really come in and like check in stops, because none of the in stops are actually connected except for beacon, and we can't do beacon, or we won't do beacon until we actually get something that we can test with the beacon. And when we go to test the beacon, because there is a glass plate, I can't guarantee that beacon's going to pick up through the glass plate. So what I will probably do is put a plate on the bed for the initial triggering, just to make sure it's going to trigger. And then we'll have to test some things to make sure that we can read through the glass, because I still don't know how thick the glass is. And I don't want to stand the chance of shattering the glass. Once again, from previous the previous videos, we have a basic printer config file. We've just tidied it up. I tend to do this little box at the top to kind of outline what it is we're working with. So the printer is an Optimus P1 Pro. It's using a BTT Manta M5P with TMC 2209s for X and Y. A BTT CB2 single board computer for the host. Bluestorm Terra toolhead with CAN bus. Physical in stops on X and Y. A beacon for probing an input shaper. And then a Canovo 120 volt silicon heater. That's not what it is. I've got to kind of get up underneath to check and see if there is a name brand on it. At this point, I may just have to go and look at the specs for it and say it's this wattage heater and just go with it. The other thing that I don't have listed here is we'll add a line. Whoops. Add a line. And it's hand pose HPD 970 stepper drivers for Z. Okay. Of course, we've got our MCU1, which is the Bluestorm Terra toolhead board. And then the CB2. The CB2 is set up as a secondary, or as a controller, a Klipper controller, because we have to do that in order to run the fan. So there's a separate connector on this board for the Pi fan. Be careful. Normally you're running those directly off the GPIO, and they're 5 volt. This one here is VBB in.
So whatever voltage you're bringing to the board, whether it's 12 volt or 24 volt, is what this fan is. If you connect it here, and then the always on fan is the same thing. You cannot voltage select those. The only two fans you can voltage select are fan 0 and fan 1. Hey, Bearded Printer, welcome in. I'll have a taco for you, Jedi Spidey. You know, standard information up here. The include section, right now, it's just including mainsail. I have 0 macros created for this. I will have to bring over a macros file and start really trying to tweak the heck out of it to get, like, you know, a print start and stuff like that. Line purge we'll add back in so we can do a purge next to the item. Camp is going to be built into Klipper at this point. We have no nozzle scrubbing. I don't even know if we can get it off the build plate to even put a nozzle scrubber in this printer. We'll have to see. The printer stuff here, it is Cartesian. All of this is basically default except for the max Z velocity in Excel. They were increased a bit because the Z axis is using ball screws. NEMA 23 motors with SU 1610 ball screws. So there's 16 millimeter, 10 millimeter lead ball screws. Okay. And I was reading some stuff on there, and this was some of the suggestions. Okay, the resonance tester is going to be the beacon. You had a choice. You could do beacon or you could do the toolhead board. Beacon is sitting right next to your nozzle. That's where you want it, is as close to the nozzle as possible. X, we're looking at 32 micro steps to start with, and 40 for the rotation distance, 200. This is all just standard NEMA 17 stuff. Is it going to be going in the right direction? Have no idea. We'll have to try it and figure it out. Do the Ys have to go? Well, let me think about this. The Ys are, so there's 2 Y motors running off of a single stepper driver. So the Y motors have to be positioned in the same direction. So they should be the same. Position in stop is set at 600. Once again, this is a 600 by 600 by 1 meter. And this homes all the way to the right. So the 600 for X. Position min would be 0. Position max 600. Homing speed is kind of slow. We'll probably leave it there and we'll ramp it up as necessary. Homing in the positive direction is true. We are using 2209s for X, so we've got that stuff set. Y, same basic settings, except the position in stop is 0. It homes to the front of the machine, so that's going to be Y0. So position min, position max, same homing speed. Homing direction, or homing positive direction, is false here. Once again, we're coming to the front, which is the negative. And YTMC stuff is there. Z, we're going to send step, direction, and enable. Micro steps and rotation distance and all that stuff, at least micro steps, is all done via the dip switch settings on the driver. So I'm going to comment out micro steps. Rotation distance for every 1 full turn, it's for every 1 full turn, it is 10 millimeters of travel on these ball screws, because it's an SU 1610 ball screw. 16 is the diameter of the ball screw, which is 16 millimeters. 10 is the lead, so 1 rotation is 10 millimeters.
Full steps per rotation is still 200, I believe, on those NEMA 23 stepper motors. We commented out the in-stop pin because we will be using the beacon probe. Homing retract distance is set to 0 per beacon requirements. Position max 1000, position min -5. That gives us a little bit of room for when we do the calibration. Homing speed 30. Second homing speed is 10. This is a little bit higher than normal because once again we're running ball screws. They're a little bit different than lead screws, and I'm not sure. We may have to increase these speeds a little bit from what I was reading. I don't know. I guess I could try and look at the OrangeStorm Giga. Does the OrangeStorm Giga use ball screws or lead screws? Does anybody know? We are not running TMC drivers. To my knowledge, they are not TMC drivers. I did take the cover and pop the board off of one of these drivers. It actually has a Stem 32 controller on it, which is a little weird, but okay. Sorry, folks. Bear with me 1 second. The TMC section here is commented out. I left it there just so the pins are there if somebody ever reuses this or uses a different driver or whatnot. The extruder is pointing to the pins on the Bluestorm Terra, and this is a copy and paste from the files provided by Luke's lab. Yeah. Out of the one of these files, this one I think. Install beacon, edit printer config. Yeah, I basically took this, copy and paste. Okay, this is all the extruder settings. It's got the information for the LGX Pro already in here. The heater pin, it's got the PT1000 for the tube. It does a verify heater. This has to happen. It needs to be there. Otherwise, Klipper will error out. And then, the TMC 2209 for the extruder motor, because that's what's on the OrangeStorm Giga board. So that's what we use there. So that was all a straight cut and paste. This is the original. This is the extruder port on the board. I left that there. The filament switch sensor, all of that. We may... no, because the filament detect that goes to the screen is coming out of E or D, which is no longer used at all, I think. So, nope. It's coming out of B. Yeah, there was a filament runout sensor on the side of the cabinet, wasn't there, Waters? Okay, what is this? TR8x4 trapezoidal lead screws and dual 48-volt steppers eliminate layer shifts in 900mm tall prints, achieving 99% shift reduction versus NEMA 17 systems. Okay. I mean, like I said, we can always pump 48 volts into these stepper drivers. They're good to 90 volts, according to their spec sheet. Yeah, and I do have a filament runout sensor from the OrangeStorm Giga toolhead. So we do have something that we could try and wire in there if the other sensor was busted. Long story short, we can figure out how to wire it in and use it. Because for whatever reason, the filament runout sensor went to the screen, and that was in B, right? And B includes the steppers for X and Y, or maybe not X, but definitely Y. So we should be able to use that same wire, maybe have to change the pins if needed, and then move it from here onto the board, and we should be good. So we can set that up. Heater bed thermal stuff. Yeah, this is configured, I'll say, semi-standard with a brain fart. This is basically set up like you would a Trident or a 2.4 or anything like that, right? So 70% max power, 120 max temp. We probably won't do that. We will probably not print anything other than PLA or a hefty amount of glue stick. We will have to run a PID on that. We will have to PID tune the tube as well. We have the heater fan. We have output. So heater fan, fan 1, which would be the, this heater fan is the hot end cooling fan. Fan 1 should be the part cooling fan if I remember right. And then this is the one on the CB2. Interesting to note, the Manta M5P base config has pins listed for CB1 and Raspberry Pi. So if you're plugging in a Raspberry Pi, it's GPIO 26. If you're plugging in a CB1, it's GPIO 79. If you're plugging in a CB2, it's GPIO 19. And I had to go dig that out because it's linked to pin 37. So this Pi fan header is linked to pin 37. So you have to go figure out what pin 37 is. And in the case of the CB2, pin 37 is tied to GPIO 19. And it's set to turn on anytime the extruder is set to 50 degrees or higher. We've got temperature sensor for the CP2 and the controller. We've got the basic beacon stuff set up here. This is directly from their Bluestorm Terra install guide as far as the offsets go. We added the Z-Safe Home and set it to 300 by 300, which is the center of the bed for the Optimus P1. I took Z-Tilt out because our Z's are on the same stepper. Well, excuse me. They're on separate stepper drivers, but they're tied in and getting the same enable pin stuff. We would have to, we could, in theory, set them up to be separate, to get separate signaling, and then we could do Z-tilt adjust if need be. But the bed drops all the way to the bottom when power's shut off, just due to the way of the bed, and they're on ball screws. So, yeah, the bed will be level unless the frame is completely whacked out, which it's a steel frame. So, is the toolhead runout sensor not wired into the toolhead board? There is no toolhead runout sensor in an LGX. Is there a spot for a toolhead runout sensor? Yes. But even the OrangeStorm Giga doesn't have it at the toolhead. It's over by the filament spool itself. It is a remote, or I think it is. I believe it is. Bed mesh, yeah, I put in some random stuff. Minimum of 20 by 20, maximum of 580 by 580. Probe count 300 by 300. It's a large bed, so might as well go large. It's beacon, so it's going to do this anyhow. And we'll work on the speed as we get it moving. And then the rest of this is all commented out. So that is all she wrote. Now, what we can do, I must have changed something. Okay, now what we can do is come over here and just verify a couple of things. Like we should have a fan 1 here. This should be our part cooling fan. And I'm getting fans, both are running, so and they are pushing a great deal of air. So dual 5015s blowing down. I do not have a nozzle in this at the moment. I need to determine what size nozzle. I'm probably going to put a 1mm nozzle in it. I'm gonna see about doing the glass. We got to be careful. I don't know if it's going to detect through the glass fast enough. So we're going to have to check that out. It's going to be a little iffy initially. We're going to have to play around with speeds, but that's stuff that I cannot do until I get there. We may be going too slow. We may need to speed it up. Who knows? But yeah, the next stage is where we really get to start playing with stuff. We've got basic config here. We're talking to the beacon. We've got our fans working. There is no hot end fan in this setup. So, the pins are defined, but we're not using one. I don't even think there's a provision to put one on it. The LGX should be going in the right direction by default because it's a drop and replace on the thingamabobber. So yeah, the next steps would be to be testing stuff out at the shop. And yeah, that's kind of where we're going to be at, or a piece of glass from the hardware store. Well, there's glass there, which I think everybody says it's a piece of glass from the hardware store. Okay. I'm going to test with the glass that's there. We have this big button on here called an e-stop for a reason. And we can let it start coming up and see if it triggers, and if it doesn't, slam the e-stop. I'm fine. I'm fine. The first time we go to move it, 1, I'm going to be there. And then 2, my hand's going to be near that e-stop, and if we need to, we e-stop it. Like I said, I need to do some work on setting up some macros for this. I'm quite honest with you, I'm going to basically grab all of my print start macros and just uncomment things like Z tilt adjust or QGL, whichever one is in that, whichever one I grab from. So Awesome, Waters. So we're gonna have to figure out some more permanent wiring for the CAN bus cable. And once again, the beacon cable should be long enough. It's 5 meters. If anything, it's going to be too long. The toolboard cable is only 3 meters. It may not be long enough. Okay. I have ordered some 3DO cable and the pins so that we can make our own CAN bus cable. So that's one thing that we'll be doing. The other thing is I know that the beacon cable is cable chain rated. I'm trying to remember if the SB2209 cable is or not. I'll still run it. Kind of won't care. I'll still run it. I've got other wire coming in. Well, that's the thing is all of the CAN bus cables that come are sized for a 350, and I think they're like 3 meters long. So I don't know if we can get it up through the cable chain, through the other cable chain, back to the middle of the printer and out is where I'm kind of going. I mean, worst case scenario, we just kind of throw it up and over for now to get in and start testing. But I think we'll be good with, we'll extend the cable if we need to. Right, that's basically where we're at. Yeah, it's got to be about 2 meters of cable chain with the way it is. So that's where I'm saying I don't know if it will be long enough, and we may have to just extend it. I do have some other pieces, like if we needed to do an extension, we would do microfit 3 to microfit 3 at that extension joint and then extend it out. That way it's still serviceable. And then down the road, like I said, I just ordered, I think 15 meters of the 3DO, 3DO CAN bus cable. We'll figure it out, Waters. We'll figure it out. That's another problem for another day. All right. With that said, folks, this is all I really had planned for this evening. We've been going for just over 3 hours. We have validated that everything we had operating on the bench is now operating out of the case. The one thing that I'm going to have to do is set up the wireless LAN. And in fact, let me double check. I may have actually set it up for Ecovate's wireless LAN. So give me a second. Pi, Raspberry. Okay. I'm going to pull this over here so I don't show your all's wireless LAN if it is in there and configured. Ooh, you know what? I may not have set it up at all because the CB2 you actually install the image with Balana Etcher. So yeah, I'll go to bed on time. It's not like I'm sitting here drinking an energy drink at 9 o'clock. But yeah, I'll double check and I'll try and set up the wireless network so that when we get there tomorrow, we hang this thing, we apply power, we can see about getting this on the network without having to run a long network cable, because that would suck. But, all right, everybody. Thanks again for being here. Thanks for hanging out. Let's see who we can raid over into. See what comes up when we look at the raid. Stephen Poole, Polymakers up and running, Free Heathens up and running, Declarations, Tuner, Jano. We haven't gone over to Jano in a while. It's been a hot minute. So let's raid over into Big Jano. Some of you are probably already sitting over there anyhow. Looks like he's working on another CAD project. So thank you all for being here. Please go with me as we raid over into Big Jano and show him some of the big love that we have for him in the community. I'm looking forward to getting this on that Optimus P1 printer and testing it out and hopefully pushing some plastic through it soon. Thank you so much for the love and support. There's a lot of good things coming this year, so stay around, stick with us, and I will see you guys later. Thanks all. Have a great night. Bye now. And for those of you that are watching this on YouTube later on, thank you for being here as well. Please, if you like the content that you see today, please click that like button below. Be sure to subscribe, and YouTube's going to be notifying you of a future video right here. Thank you.